Alright, so I wanted to show how I am making the tubes for my suppressors. So I've already got one side, I saw cut them to really close. Then I've got one side that I've bored out and threaded for my threads. And the other side is still, it's faced off, but I haven't bored it or done any threads. And it's still too long. So the way I'm doing this is now that one side's done, one side's faced off, I'm going to take my calipers, my big calipers, and I'm going to measure the length. Now, right now I've got about 6 inches and 938 thousandths, which I'm going to go down to 6 3/4, relatively exact with, plus or minus a couple thou. So I measure it, then I'm going to take it over to my CNC lathe. Now, here in my CNC lathe, I have soft jaws that I've made and I've bored out to exactly 1.5 inches diameter. And then I've also turned my hydraulic pressure down on the machine so I don't squish my tubing. And you can even see I put a note here on my jaws saying that this is the diameter that they're for, and then how to mount them on the chuck. And then the jaws are also numbered on the chuck, and they're numbered themselves, so I match up the numbers on the chuck to the numbers on the jaws. But so what I'm going to do is I'm going to put this suppressor tube in here. I'm going to close the jaws, and then what I'm going to do is I'm going to actually spin it and hand jog it over. And I'm going to come really close to it, and I'm going to touch off. Now, as soon as I touch off, I probably took off a thou or two, but it's okay. That's close enough for what I'm doing. It's just length. Then I'm going to stop the spindle, and then I'm going to select my Z-axis, and I'm going to origin it out to zero it out. Now, since I know that my tube is 6 inches 938 thousandths, and what I want to be is 7 inches or 6 inches and 3/4. What I'm going to do is take off the difference. So that would be 100 and about 88 thousandths. And then what I'm going to do is I'm going to origin that out, zero it again so I know where my zero is. Then I'm going to go to my offset page, and I'm using work offset G56, and I'm going to hit Z face measure, and that's going to set the new zero to exactly the spot where it's going to be 6 3/4 inches long, and then it's going to face it off, and it's going to face off to where I've set that work offset in my program. So now, since I'm taking off a pretty good bit, since I've got to face off a pretty good bit, I'm going to go to my positions page, and I'm going to take off roughly 100-ish thousandths by hand. So I'm going to spin the chuck, and I'm just going to hand jog it and take a cut. Now, I could make my program take it in small steps. I just haven't made my program do that. I'll stop the machine, get my titanium chip out there, and then at this point I am basically ready to go into the program, close the door because the coolant's going to get everywhere, and I'm going to hit cycle start. So now this program is going to face off, then it's going to bring up the boring bar, and it's going to bore out the hole to my exact size. That's what it's doing right now. It's changing tools to bore out. It's going to bore out to the right diameter, and then it's going to thread it to my threads. And then after this part is done, I'm going to take one of these finished tubes that are threaded on both ends and made to the right length, and I'm going to take it over to the CNC mill and cut the spiral flutes. Alright, so now the next step I'm going to do is I'm going to cut all these spiral flutes in the tube just to give it a little bit of character. And I'm starting out with a tube that is threaded on both ends. Alright, so now here is the setup in my CNC mill. So this rotary is a little bit large for my mill, honestly, but I made it all work. So what I've got here is, this is a 4th axis and for the machine. So I made my own adapter plate that is also a set true adapter plate that I made and designed for this specific thing, for this collet chuck that I purchased. This collet chuck, once it's mounted, I can actually take and I can put a dowel pin or something that's, you know, precision ground, and I can indicate this in true using these different set screws on this adapter plate to set that collet chuck on true. So I take the tube and I've made this piece also that's threaded to the same exact threads on this tube, and I also had to make / modify an existing tailstock, because a tailstock that I bought from another guy, it was just way too big for this machine. So I had this thing that was kind of messed up laying around. I had to add some weld on the bottom and remachine it to tighten it up to the T-slot in here. Then I had to make all this, and I machined it to where it is perfectly on center with this collet chuck. So if anyone's wondering why it takes me so long to make these after I started it, that's the reason why, because I have to make about 1.5 million, it seems, parts just to make the end product. So then I've got this messed up end cap that I kept that I'm going to thread into the other end, and it's cut to exactly a 60-degree center, which is this is basically a dead center, but that's what this is cut on. Then I'm going to take my homemade spanner wrench, just another thing I had to make these, and I'm just going to kind of snug it up. I'm going to put my tailstock in place, lock it down. Then I'm going to take and tighten the quill. And then I'm going to lock the quill down. And unlike the lathe on the mill, these are the same exact length now, so the work offset is set to this end, so I don't have to adjust anything, it's already set. Then I go up to my 90s era machine and I hit cycle start. And now it's going to cut my spiral flutes. So that's kind of how I do the tubes, which is just one piece of the suppressor. A lot of people have been asking me, you know, kind of how I've been doing it. A lot of people have been really curious about it, so I just thought I'd show it a little bit of the process. I appreciate everybody's business, and I also appreciate the interest in this. This is kind of exciting.